Hey guys, welcome to day 2 of 7.3. So we're looking at shells, but a fancier version of them. And we're going to start same way by graphing region, shading it in, and seeing how we're rotating it. So take a look first at this example. First, A and B, same line, same region, different methods. So I want you to see a side by side. So this is going to be the last day we're talking about these. So we'll have quite a bit of review here. I really want you to get the process down today. Okay, so looking at this first one, y equals 4x minus x squared and y equals x squared. We know what this looks like. Let's graph this first to kind of see where intercepts are. If you factor an x out, you get 4 minus x, so we know we're crossing at 4 and 0, which makes 2. The middle, your line of symmetry. Let's find out where both curves intersect. We can also sub a 2 in here to get 4. So we have this downward parabola. Let's find the intersection to find out what we're integrating over. So we'll set these guys equal. We'll move everything to one side. Go ahead and factor. Would they be x minus 2? So we're actually intersecting at, what, 0 and 2? So we graphed this function because it was a little more restrictive, saw what we have. We know how to graph the parent function, and look, it says we're intersecting at 2. If you sub a 2 in here, you get 4 out, and there's your region. Okay, while we drew it here, now we're going to look at our method. Shell is parallel. We're going along the line x equals negative 2. So we're revolving around this line right here. Okay, so like I just said, shell is parallel. If this is my line, our rectangles go this way. Now, again, picture this rectangle swinging around this line. It's going to swing this way, where this is our radius and this is our height. Okay, so shell has a scalar. Remember, these are cylindrical shells. So it's like the soup can label, that's 2 pi r/h. Look at these rectangles. They get stacked up. If you keep drawing them and extend, they hit the x-axis. X goes from 0 to 2. These are x values. So now we need an r and we need an h. You don't have to do this in your homework. It helps though when you're starting out. So this is the radius. Now look, the radius is always going to change. As this pink rectangle moves to the right, the radius gets bigger. As the pink rectangle moves to the left, the radius gets smaller. The radius is a horizontal line. It's going to be right minus left. But the right keeps changing. It's whatever x is. Minus the left is negative 2. The height, vertical line is top minus bottom. We have 4x minus x squared dx. The other good news about today is we are only just setting these up. So x plus 2, this will give us negative 2x squared plus 4x, and then I'll leave you here. I'll tell you that you would want to expand this to finish it. I really just focused on your setup. I'm really confident you guys are awesome at integrating these. Okay, now let's look at disc and washer with the same method. I'm sorry, same region, different method. So now we have this, and we already know what our region looks like here. So I'm just going to sketch this again rather quickly. This is our region that we have. We're rotating this around the line x equals negative 2. Okay, so now disc and washer. Which one is this? Look at the line of rotation and look at the shaded region. Because you have this void here, you know what, I'm going to fix this because it's supposed to come up like that. Okay, so you have this void here, and because we have the void, we know that it's going to be washer. You put your marker on the line of rotation, and you go to the curve furthest away. Do the same thing here, line of rotation, closest curve. So what it's doing is it's taking everything and taking out the dead space. So V equals pi. These rectangles, let's fill this in, this was 2, 4. These rectangles, they keep touching the y-axis, and y goes from 0 to 4. Notice that I put pi in front. Remember, that's because as this circle revolves, as the rectangle rotates or revolves, it makes a circle, so we need pi r squared. This is the radius. The radius is this curve which is this function, but I need y. So I'm going to come up here and solve this for y minus the left. So x equals root y minus x equals -2. Square it. That's too much. We need to take out the orange. The orange is x equals. Now, I hope you're realizing that we have a problem here. So a big uh-oh here, because when we come over here and we try solving this, because if I want y in this, just like y is here, I need x equals. So I need to solve y equals 4x minus x squared for x. But, so we need to solve that function for x, but we can't. You might try factoring an x out of here, but then you get 4 minus x. You just can't isolate it. So this is a case where even though it looks like both methods could work, the setup looked great, you run into a problem because of the algebra. Okay, going on to this. So now, same problem again. So we'll graph this rather quickly. Okay, and now we're revolving around the line y equals -1. So we're revolving around this. Shell is parallel, horizontal, horizontal. As this rectangle swings around, here's the cylinder. Again, picture, if you need to use your pencil to do it, go for it. And as it swings around, it makes a cylinder. A cylinder is 2 pi. Look at these y values. This point again was 2, 4. Y gets stacked up from 0 to 4. These are y. I need an r and I need an h. This is my r. It's a vertical distance, so it's top minus bottom. But look at this, pink is not locked in. The pink keeps changing. So it's y minus -1. Now I need a horizontal distance. I have to do right, which is this curve. So it's going to be root y minus, so now we need this left, but look what, again, I have the same problem that I had before, is that I need to solve y equals 4x minus x squared for x, but I can't. So we have to stop because there's another uh-oh. Some of you may have realized that that was going to happen because look at this problem had y, and once we started trying to solve for x to get a y, we couldn't. Same thing here. As soon as we had a y, I saw we were going to be in trouble. Okay, let's wrap this page up, and then the back is just a review also. So again, this function that's down, this function that's up, shaded region around y equals -1. Disk and washer. Which one is this going to be? Look at the shaded region. Is there a gap between that and the line of rotation? For sure. So this is washer again. Line of rotation, to curve furthest away, you go through the shaded. Line of rotation, closest curve. Okay, V equals, as a rectangle rotates perpendicular, you're creating a circle. So we're getting pi. This value is 2, 4. It keeps hitting, the rectangles keep hitting the x-axis. So x goes from 0 to 2. Okay, so now we're looking at top minus bottom for the pink, because remember we want capital R. So it's x squared minus, wait, I think I wrote the wrong one. Yep. Hopefully you guys caught that too. The top is the downward parabola, which is 4x minus x squared minus the bottom, which is -1 squared. So that's everything. Now let's take out what we don't want. So now it's x squared minus -1, all dx. We would expand this to, I guess we could clean it up a little, get -x squared plus 4x plus 1, because minus minus, and then x squared plus 1. So this problem, if anything, is just annoying. You're just expanding this function and then integrating. Okay, so expand to finish. If you want to try it on your own, go for it. But this is the setup. Okay, last page. This looks like a lot. We're just setting these up. If you look A and B, it's just like the last problem. You have 6, y equals -3, y-axis and x-axis, both methods. Let's graph it in A. And then while we have that fresh, we're just going to sketch it in all the spots. So looking at this first one, I want you to graph the most restrictive functions, or I guess like the easiest ones, just so you have a restricted graph. Y equals 0 and x equals 4. Y equals 0 is this, and we know how to graph this function. It looks like this. When x is 4, the square root of 4 is 2, so you're looking at 4, 2 here. So look at, you're bound by y equals 0, x equals 4, and the radical giving you this region. So how about we go through and graph this region on all of these. This is like the non-thinking part of it. We already graphed it. We just need to draw a picture for each one. It really helps to see the shaded region. I'm going too fast on this. You might want to hit pause. Okay, so we have all of that. Now we can just refer to it. So x equals 6 is this line right here. We're rotating around that. Zoom this up and zoom in a little for each problem. Okay, so x equals 6. Let's see. Okay. Parashell, we're parallel to this. Okay, as this swings around, creates a cylinder. This is the radius, this is the height. All shells have 2 pi. These rectangles get stacked up, they keep hitting the x-axis, they go from 0 to 4. The radius, it's a horizontal distance, so I need x in here, so I want y equals. Okay, so if we look at this first one, this gap, we have 6. Yep, we want x in here, we're good. So this distance is 6 minus, this x keeps changing on us. Okay, then I want the height. The height is the top, which is root x, minus the bottom, dx. Here's your r, here's your h. And remember that trick about subbing some numbers in? I feel like, for the most part, you guys struggle a little with this. Look at forget about what this says, and when x is 0. If I'm revolving around this line, do you see that there's a 6-unit gap? So the radius would be 6. When I sub a 0 in here, sure enough, I get 6 out. Try 4. If I'm on this point, my radius is 2. And when I sub a 4 in here, I get 2. So that's how we know we're good. Okay, let's look at y equals -3 using shell. So y is down here, -3. We're rotating around this. Okay, shell is parallel. Now our rectangles go this way. This is your radius, this is your height. They're both the heights, but I'm going to write it down here. It's kind of hard to see that. So v equals 2 pi rh. Look at these rectangles. They go this way. This point is 4, 2. They keep getting stacked up on the y-axis. So we're going from 0 to 2, and those are y values. I need an r and an h. The radius is going to keep changing as this value goes up. The radius is a vertical line, so it's top minus bottom. The top keeps changing, which is y, and the bottom is -3. And look at, I had y's and I have y's. Then the height, this is the height. Remember, the height can be sideways. So the height of this, I need y in here. So I'm going to do the right function. If I'm looking right here, it's 4. And then 4 minus the curve, because the curve is there. Now, if y equals root x, x equals y squared. So even though this is the curve, where were we, right here, even though this is the curve root x, I can't have that, I have y, so I have to write y squared. Okay, going on, those were the two hardest. Now let's look at y-axis, which is right here. Shell is parallel. This is your radius, this is your height. So v equals 2 pi. This is the 0.42. Rectangles keep touching the x-axis. X goes from 0 to 4. These are x numbers. Sorry, we lost it for a sec. Now the radius is right here, but it's really not this distance, remember, because this rectangle keeps changing. So the distance from here is going to depend on what x is, and x is minus 0. Then we're going to say the height. I have x's. It's the function, so y equals root x minus y equals 0. And of course, you guys can simplify that, just expand, multiply. Okay, last one of shell. X-axis is right here. This is the x-axis. Shell is parallel. Swing that around. This is your r, this is your h. V equals 2 pi. This point is 4, 2. These get stacked up. They hit the y-axis. They go from 0 to 2. The radius, because it's a vertical line here, it's going to be top minus bottom. The top rectangle keeps changing and it's a y value. The axis of rotation is 0. That's my r. And I did not write that up here. Okay, now the height. It's a horizontal line. So it's right minus left. The right is 4. The left is this function. We don't write square root x though because we need y's. We write y squared. Okay, we knocked those shells out. Let's do the same with disc or washer and decide what it is, whether it's disc or washer. Okay, if we revolve around the line x equals 6, do you see a gap between the shading and the line of rotation? Makes it washer. So v equals pi. Look at your, we didn't do our rectangles. Rectangles go from line of rotation to curve furthest away, and then the other rectangle goes from line of rotation to closest curve. The rectangles get stacked this way to keep hitting the y-axis. This point right here is 4, 2. Remember, we're only focusing on the shaded, even though our rectangles are in the dead space. So we go from 0 to 2, and those are y. Capital R. If I want y here, it's going to be x equals. So it's the pink, x equals 6 minus x equals, remember we already solved that, for y squared. Don't forget to square it. Now take out little r. The right of the orange is x equals 6. The left of the orange is x equals 4. They're squared independently with a dy at the end. Same thing, you would expand. Okay, going on, 3 left. Stay strong, kiddos. So y equals negative 3. This is what you're rotating around. Is there a gap between the line of rotation and the axis of symmetry? Because the answer is yes, it's washer. Line of rotation farthest away, line of rotation closest. So v equals pi. Remember, it's pi r squared. We have circles. These get stacked up. They keep hitting the x-axis, and x goes from 0 to 4. These are x values. The pink, it's top minus bottom. It's a vertical line. So it's root x minus negative 3 squared minus the orange is y equals 0 minus negative 3 squared. All dy, expand also. Okay, y-axis. Do you see the gap between the shaded and the line of rotation? Washer again. Line of rotation, farthest border. Line of rotation, closest border. V equals pi. Look at how these are stacked up. Hit the y-axis. They go from 0 to 2. The pink, I'm sorry, these are y's. If these are y's, I want x equals. So I want x equals 4 minus x equals 0. The orange, I need y's in here. Remember, x is y squared. So it's y squared minus 0 squared, all dy. Okay, very, very last one. X-axis is right here. Finally, we have a break and we can use disc. Look at, there's no gap between the shaded and the line of rotation. We're still perpendicular, but now we don't have subtraction. V equals pi. This is the point 4, 2. These rectangles are stacked up on the x-axis. They go from 0 to 4. Top, those are x's. I want x in there. So it's root x minus 0 squared. If I was going to integrate any by hand, it would be this one. Look how easy that would be. but we're pretty done. Okay, guys, hopefully you have a good feeling of shell and disc. I think we looked at every possible way today. Have a great night.